Hi, and welcome to the Kubernetes podcast from Google. I'm your host, Abdel Seguiwach.
And I'm Caslin Fields.
This week, we chatted with LeakSignal, an American startup which is building a set of tools and products to detect and prevent data exfiltration in service meshes and proxies, supporting Envoy and proxy-wasm.
But first, let's get to the news.
Dragonfly is a peer-to-peer file distribution system for cloud-native architectures and is a CNCF incubating project. The most common use case of Dragonfly is hosting and distributing container images for Kubernetes clusters.
Red Hat announced the preview of their Terraform provider for ROSA, or Red Hat OpenShift on AWS. The provider allows using Terraform to provision OpenShift clusters on AWS in addition to using the Red Hat Hybrid Cloud Console, or the ROSA CLI. The provider is available directly on the Terraform registry.
Microsoft announced the general availability of its telco offering called Azure Operator Nexus. The platform was introduced at the Mobile World Conference early this year. It supports virtualization and containerization for network functions, also known as VNFs, and integrates compute, network, and storage in a self-servicing manner via the Azure portal, the CLI, and SDK.
HashiCorp announced a change to their licenses. The company is adopting BSL, or Business Source License, on all future releases of HashiCorp products. HashiCorp APIs, SDKs, and almost all other libraries will remain MPL 2.0.
The Open Source Security Foundation introduced S2C2F, the Secure Supply Chain Consumption Framework. This new framework is a set of requirements and tools for any organization looking to adopt software supply chain security into their architecture.
The last quarter of 2023 will be busy with Kubernetes and cloud-native events. There's a lot to cover, and we'll leave some more details in the show notes. But here's a rundown of some of the major ones.
WASMCon on September 6th and 7th in Bellevue, Washington.
The Open Source Summit EU on September 19th through 21st in Bilbao, Spain.
gRPC Conf on September 20 in Sunnyvale, California.
Virtual IstioCon on September 25th and 26th.
KubeCon, Cloud Native Con, and the Open Source Summit China on September 26th through 28th in Shanghai, China.
PromCon EU on September 28th and 29th in Berlin, Germany.
KubeCon and Cloud Native Con, North America on November 6th through 9th in Chicago, Illinois.
Cube Day India on December 8th in Bangalore.
And finally, Cube Day Singapore on December 12th.
Fermyon added SQL database support to their WASM cloud platform. The company announced beta availability of the SQLite database engine. Fermyon supports developing and running serverless apps in the WASM runtime using the Spin framework. They also added support for custom domains.
Exposed Kubernetes clusters are everywhere. A new article from the security company Aquasec resumed a 3-month investigation over which the team at the company found around 350 exposed Kubernetes clusters. These are clusters that leave HTTPS ports 443 and 6443 and sometimes even HTTP ports exposed to the internet. Sometimes also leaving some API endpoints, which could allow hackers to collect important information about the internal functioning of the clusters. The team also ran some honeypot clusters and collected data about the kind of attacks they are exposed to, which seems to be for the most crypto miners. Things like this can be avoided by training your teams and setting your Kubernetes API endpoint to only be accessible from a secured perimeter. Also, using RBAC and admission control policies can help prevent lateral movements when malicious attackers find their way in.
And that's the news.
Hello, everyone, and welcome to the Kubernetes podcast by Google. I am your host, Abdel, and today we are talking with Wesley Hales and Max Bruce. So, Wesley Hales and Max Bruce are the co-founders and LeakSignal. LeakSignal is a cloud-native solution for preventing data exfiltration in web apps, workloads, and API through microsegmentation. We will dive into the details of what that means in this episode, but before we get started, welcome to the show, Wesley and Max.
Thank you. Great to be here. Honor to be here, by the way.
Awesome. Thank you for being here. I had a chat with Wesley a long time ago when LeakSignal, or whatever is LeakSignal today, was still just an idea kind of bubbling up. And I found it quite interesting. And I think I was pretty intrigued when we had that chat about the term micro-WAF, because I think that was the first time actually I hear about it. I guess we'll dive into details of what micro-WAF means. But before we get going, I think we need to introduce the guests as we usually do. So let's get going, starting with you, Wesley.
Great. Yeah. So Wesley Hales, CEO and co-founder, in collaboration with Max here, who's on the line, and also Isaac Roth is one of our co-founders, and he is the creator of OpenShift. So great team here. And I myself have been a longtime hacker, software developer, mainly focused on cybersecurity over the past decade. During that time, led engineering in a few different places, shaped security, which we kind of defined the bot protection market back in 2015, roughly, and been with many other security vendors, CDN, WAF-related, runtime application security protection, or RASP, if anyone's familiar with that, and API security. So really taking a lot of the software development history that I had and kind of converting that over to cybersecurity. So yeah, that's me.
Nice to have you. I think it's worth mentioning also that you have quite long experience, including being at Google for a while. You worked on Apigee. I think when Apigee was when we just acquired it, I guess.
That's right. Yeah. So APIs were the hotness. That was really my first Palo Alto startup experience, was joining the Apigee folks. And yeah, that was really before API security was a thing. But, APIs existed a long time before what we understand them as today. But yeah, that was very enlightening experience.
Yeah, I'm also coming from the XML RPC old school API, like world.
Oh yeah, throw some soap in there as well.
Yeah. And we have Max. Can you introduce yourself, Max?
Yeah, my name is Max Bruce. I'm CTO at LeakSignal. I've been a software engineer focusing on layer 7 cybersecurity / AppSec for the last 5 years or so. My most notable project that I've worked on is KeyHouse, key management system at ByteDance that uses spiffy IDs for service authorization. I love engineering.
Awesome. Well, great to have you, folks. So I think let's get going by what is LeakSignal? What are you guys trying to solve?
We started this idea about a year and a half ago, and it was really about the future of architecture and infrastructure and really providing cybersecurity in that environment without being a black box kind of vendor that you have to pay millions of dollars a year for, right? So we were looking at it from multiple angles, the open source angle, the cloud native kind of journey, and what does that mean to platform engineering, if that's what you want to call it, right? DevOps, et cetera. But overall, coming from the background that we have, we knew that legacy security solutions, again, were very closed off, not open, and we're disconnected from microservices and kind of where the direction that everyone seems to be heading. So in that, for the past 25 years, roughly, cybersecurity solutions have been looking at what's coming in the front door, right, to determine if this is a good or bad user. Is it a bad IP address? Is it a bad user agent? Did they type the right things on the keyboard? So that, I guess, solution has kind of come and has raised the bar for attackers, but attackers are easily bypassing what exists today. So you combine kind of what exists in the new architecture, the mesh, and you take what we had from a legacy standpoint and you look at that and say, okay, what can we do better? And so LeakSignal is really about analyzing layer 4 through 7 traffic in real time, in line, and doing that also on the request and the response. So not just looking at request signals like we've been doing for the past 25 years, but also looking at the full response body, no matter what protocol it's traveling over, gRPC, WebSockets, HTTP, and kind of bringing that together in a WebAssembly. Like WebAssembly kind of empowered this. So I'll stop right there. That was kind of the high level overview.
I think you mentioned quite a lot of things, and I'd like to kind of go into details a little bit. So one thing interesting you mentioned is the last 25 years, security for traffic have been mostly focused on what we could call the edge. So let's secure the front door, the API gateway, whatever, that load balancer where traffic comes from outside. But there is more and more interest in security around microservices themselves with things like Zero Trust with MTLS, what you folks are doing, and also things like spiffy that Max have mentioned, like authentication between microservices without having to implement code to implement such authentication, right? The way LeakSignal implement things, you folks are basically mostly focusing on Envoy, right?
Well, we've expanded since then. So we support Nginx and Lambda as well.
Lambda as in AWS Lambda?
That's right.
Yes.
Okay. So basically you support whatever supports proxy-wasm.
Correct.
And more.
And more, okay.
So we support whatever supports proxy-wasm, but then we also have a native Nginx module.
Okay.
And then Lambda doesn't run proxy-wasm at all.
So we're shimming until the WebAssembly runtimes are kind of pervasive.
Yeah, so that's because, as we have discussed in the previous episode, WebAssembly is still a bunch of undefined things that is still being worked on. So let's go back 1 second. Can you explain to me what is proxy-wasm?
Proxy-wasm is a recent standard for deploying WASM modules and reverse proxies, such as Envoy and Nginx, most notably Envoy. It allows all the capabilities of a native plugin or module to the reverse proxies while being generic across different reverse proxies. And it also provides a safe sandbox. It's running in V8 engine or some other WASM engine. And so some kind of crash in your module won't bring down your entire reverse proxy and therefore your entire service. It's been a bit quiet on the community stage the last few years. It's kind of at a stable state as it is. While it doesn't get a lot of visibility, we do see a lot of real potential for it as kind of like a runtime environment for distributed middleware. Notably, everybody's already running this with Istio and OpenShift Service Mesh. You've already got proxy-wasm modules running and collecting telemetry on your cluster.
Yeah, Istio have moved actually to proxy-wasm from implementing WASM directly in Istio itself. But I was looking at the GitHub repository today, and I think, is the Nginx implementation fully defined, or is it also still work in progress?
I might get the name wrong, but I believe his APISIX is working on an Nginx proxy-wasm implementation. We considered using it, and we do have some integration with it. However, it, last I checked, doesn't support gRPC outbound streams. Mm-hmm. So we've held off on having first-class support for it at the moment, but it does exist.
Okay. So is this proxy-wasm something that developers in general will have to worry about in the next couple of years, or is this more like a framework where you would be able to use a plugin like yours and just run it inside proxy-wasm without having to worry that it runs there? How do you see this thing progressing?
I see it a lot as like a back end, like a backhaul for implementing higher level services so that your average, engineer working in the mesh environment won't need to deal or even think or know about proxy-wasm. However, it'll be the people implementing authorization plugins, custom telemetry, stuff like LeakSignal is going to be where you're going to get that interface with proxy-wasm.
Yeah. The reason I asked that is because when I looked at the GitHub repository, I saw that there was, you have the specs and the implementation for the different proxies, including Envoy and Istio and whatever, but you also have an SDK for Go and C++. And that's why I was wondering, is this something that an average developer will have to use at some point? But I guess it depends. If you're an end user, probably not. But if you're working in a company building plugins, then probably yes.
Yeah. Yeah, so we actually, long story there, but at a very high level, proxy-wasm gives us kind of a fault-tolerant or virtual machine to plug into that Max was saying is kind of like a distributed middleware that sits in front of the services, right? And it allows you to deploy traffic analysis, things like LeakSignal, pretty easily, right? Because you just kind of plug it in, right? That's the whole idea without having to bring anything extra. So it's a very confined kind of computing environment, but at the same time provides a lot of power and possibilities as well. Yeah.
Cool. So there is one thing I'm curious about, considering your position and you're exposed quite a lot to customers using Envoy. A lot of times when we bring up Envoy, it's usually brought up in the context of Istio as a sidecar. And even Istio now is sort of dropping Envoy for the ambient mesh new architecture, kind of, right? But I think my question is, do you see Envoy being used as just a standalone proxy outside of Istio? Because that's how it was designed by Lyft in the first place, right?
Yeah. So, as we have kind of, the startup portion of this, right, taken this product to market and validated it with design partners, it's been interesting because no infrastructure is the same. We talk to some organizations that have 3,000 to 4,000 or even 15,000 microservices managed by OpenShift or Istio. And then you talk to some that say, hey, we've got a microservices environment, but we've also got all these legacy things going on. So, our approach is really, if this is valuable enough, then the tolerance to put an Envoy proxy in front of these systems, they're accepting of that, right? And they will do that. Just to get the value out of this type of traffic analysis, you really have to put either Envoy or some other mechanism, some reverse proxy in front of those existing systems.
Yeah, you need something inline, basically. Mm-hmm. And it seems to me the way you're describing it is that your WASM plugin plus your cloud control, which we're going to talk about a little bit, would even work with a legacy system, right? So it doesn't really have to be microservices. It could be a monolith app and you just stick an Envoy in front of it.
Yeah. And, going back to the past 10, 15 years of cybersecurity, right? I come from a time where we were taking 1U network appliances and asking customers to put our appliance in line with live traffic, right? So you kind of take this into the new era And it's kind of the same concept, right? You're putting something in front of that system, but here it's getting much more elegant and it's getting less friction is involved with these newer kind of solutions, right?
Yeah, it's quite interesting actually to see all the debates and discussions around Envoy. As I said, is the context of service mesh, but I know at least one customer, I don't think I know, I can say the name, but I know at least one company, one very large company using actually Envoy as just like a layer 7 proxy in front of all their north, south, and east-west traffic. So it is a very powerful proxy because it's pretty lightweight.
Yeah, we're dealing with one particular financial organization that has 1.5 million requests per second on the ingress and scaling 3,000 to 4,000 Envoy instances there, right?
Wow, as a proxy layer.
As a proxy layer. Yeah.
Wow, that's quite cool. That's interesting. Yeah, I think also because even at Google, we are moving away, that's a big term, but we introduced a new set of load balancers which are based on Envoy, right? So GCLB, which is Google Cloud Load Balancer, was always based on GFE, which is our own proxy, Google frontend. But we introduced a new set of load balancers which are based on Envoy itself.
Yeah, I saw also that you guys took Nginx out of kind of the infrastructure layer as well and replace that with Envoy for like all of Google's services, all the Google Cloud services as well?
It's in progress, but yes, that's the direction in which they're going. Yeah. I think the main attraction there is being able to offer all the capabilities that Envoy offer in a native way, because it has a very extensive API. And it's quite frankly quite intimidating if you're not really used to configure Envoy with YAML files. But once you understand how it works, it's really, really capable.
Yeah, totally. And that's our approach too, right? If it's kind of tied into the DNA of what cloud native is or what the future of monitoring and infrastructure is, then, it kind of makes sense, right? So
yeah, awesome. So let's then go back a little bit. Can you explain to me how does LeakSignal systems work?
So at the highest level, we've got two main components that are going to get deployed. One is what we call our proxy, and that's what we've been talking about. That's proxy-wasm, a direct native Nginx integration, Lambda integration, etc. But then the other main module there is what we call command, or LeakSignal command. It's an asynchronous to live traffic service that is in charge of collecting telemetry and then analyzing it and making like higher level policy decisions. So, it's going to do your distributed rate limiting. It's going to do your, complex traffic analysis, like looking for traces in the network and doing like a different alerting or blocking based on that. And then on the proxy side is where we're going to do things like microsegmentation, which is like, hey, does this user have access to this resource? It's looking at that per request kind of level, and then uploading that telemetry to command where it can then, be aggregated and analyzed.
Yeah. And command comes in the form of both a cloud-hosted version, right?
Yeah, we have both a cloud-hosted version and an on-prem deployment.
Okay, so customers could potentially just deploy the control plane if we dare call it the control plane, but they can deploy command on-prem if they don't want to do cloud, essentially.
Yeah.
Cool.
Yeah, and we strip that down too. I mean, we have this command environment that manages the policies and does all these great things with the telemetry, right? But if you kind of rewind a bit, the module itself, the proxy-wasm module or the Nginx module, it does all the processing in line. So we're not shipping out sensitive data for it to be further analyzed somewhere else. We're classifying. So really at the core of what LeakSignal does is we're classifying sensitive data on the request and the response. So if it's a 200 kilobyte response body, we're going to be classifying that in real time, collecting the metrics around that, like what matchers occurred, what was their social security numbers here, was their customer data, and then taking that telemetry based on that and sending it to command or Prometheus if you don't want to use command, right? So we're truly cloud native. You can go straight from the module to Prometheus even if you want to.
Yeah, I was about to mention that you have also support for Prometheus in the OpenTelemetry data spec, right? So basically, you don't have to use command. You can just have a self-hosted Prometheus and Grafana, and you get all these metrics on-prem.
Yeah, it's all available today on GitHub. I mean, it can be used by anyone for free today.
Cool. I think I'd like to stop here and rewind a little bit because we talked about a lot. Like your plugin can do a lot of things. It can do, of course, it can do two main things: analysis and policy enforcement, right? So traffic analysis inline, that's pretty clear. You're basically looking at requests and responses as they are going from one microservice to another and collecting telemetry about what these microservices are, what the traffic is. But the term leak have a very special connotation, which is essentially preventing leaks or preventing data exfiltration. So can we maybe give like very specific examples of what are you trying to avoid leaking using your plugin?
if you start with how do these data leaks occur? I mean, if you follow any channel, Twitter, Reddit, whatever, you're going to see data leaks are occurring on almost a weekly basis, right? And it's usually through the form of API exploits and misconfigurations and those types of things leak data. And it could just be, an error in the production logic. But at the end of all this, the only way to figure out if you are leaking data is by classifying sensitive data on its way out, either east-west or north-south. So that was really the thing we wanted to master first and do that very performantly, right? Because initial prototypes of scanning full response bodies in real time in Envoy proxy, in proxy-wasm, there was like 100 millisecond latency, 200 milli, and that was really before Max was able to come on board and rewrite it. But now we are under 1 millisecond in terms of latency of doing that processing in line, right? So once you understand the outflows of sensitive data from an individual service, even if you have thousands of services, you can understand what normal is.
Yeah.
What is an API request? Does it only return a response body with one customer record in it every time? And when it returns one with 50 in it, then there's something wrong, right? And that's really the type of visibility we're trying to bring with that in terms of leak detection, right?
Yeah. So that's actually one of the interesting things about the product is as you describe in it, like you're looking at the traffic, building the baseline, sort of figuring out what normal looks like. And then when something doesn't look normal, then you say, okay, well, this is a problem, right?
That's right.
But the cool thing is they are doing it in layer 7. So you're able to actually look at the actual HTTP requests and extract things like social security numbers, credit card numbers, things like that, right?
That's right. Yeah. So once you understand that and you understand what normal is, then from a forensics or investigation standpoint, we can audit everything in the response that's going out. And so it's full attestation, if you will, from a cybersecurity standpoint. What data was accessed by, for example, an individual auth token. So if you take a JOT token, for example, and you correlate that with the sensitive data, then we have a token to sensitive data ratio.
Yeah.
And so that allows us to understand, did this individual token that could have been phished along the way and someone's just accessing an API, did this token exploit an API and get more data than it should have? Or did someone just force a token, and it was brokered as the connection entered the infrastructure? And, do we have a bad architecture and a single token is scoped to access a ton of different customer data, right?
Yeah, that's actually quite interesting. I've never thought about this token to data ratio. That's an interesting approach of looking at what's a normal identity, because that's what a token is, right? What normal identity typically does in terms of moving data around. And then you can say, okay, well, now I see that this particular token that have been doing the same thing for a while, now it's just extracting more data than normal, then that potentially could be a problem, right?
That's right. Yeah. So that's what it's really, we're providing a new type of visibility after MFA occurs. So after someone logs in, they go through all the checks, all they have is a token. All that request has is a token. So it's really, and every environment's different. No one really has visibility into that space. So that's really what we're trying to bubble up to our customers and users.
Cool. So that's the proxy-wasm plugin side of things. So that's the data leak prevention. And then you have the telemetry and visibility part, which is what Command does, or potentially Prometheus or whatever, right?
Yeah.
And so that's where you collect metrics about what's normal and what's not normal.
Yeah. So another big aspect of what we do is microsegmentation as well, but we're doing it based on sensitive data. Historically, microsegmentation has been layered 3 through 4, certificate management, that type of thing. But when you apply this WASM module, which you can do with a single line of YAML, right? You apply it, kubectl apply, and then from there, we can automatically microsegment the network based on the sensitive data that the services handle. So if you have 4,000 services and you don't really have visibility into that environment, we kind of do that within minutes, right? So you deploy the module, we automatically group the services together based on what data they're touching. And then that gives you like instant PCI compliance, right? From a data flow perspective.
Cool. Yeah, that's also quite interesting. Then the third aspect, I think, is the policy part, right? So can we talk a little bit about that? Like, what does the policy part does?
So our policy has two kind of main rule engines inside of it on the enforcement side. And then we've also got a separate, what we call a matching engine on the detection side. So our matching engine and all of this is defined in our policy as a whole. On the matching engine side, you've got like, hey, I want to look for social security numbers or credit card numbers, user IDs, emails, whatever. Whatever is sensitive in your environment for your given compliance that you're looking for, that's what your matching rules are there to find. And then on the policy enforcement side, we've got two different sides of this. One is what we call SBAC, or service-based access control. It covers a wide range of different filters and groupings that you can do, and that all gets acted live inline in that proxy. So it gets access to the data, sensitive data that might not get transmitted up to command. And that allows you to do like that inline blocking, redaction, etc. But then we have what we call our rule system, like our just general rule system, which is what's going to operate in command. And this is going to do things like alerting and blocking on metadata that is aggregated between request and response. So you could say like, hey, I'm going to look at all the sensitive data access for all given tokens grouped by token over the last hour. And then, if I see any tokens with accessing more than X amount, then alert or rate limit. And then those rules get evaluated continuously. And then any kind of rate limits or alerts that they do get propagated out.
Yeah. So you are able to do basically on the spot controls by configuring the rule that says if a token is extracting more data than it should be, just block it or rate limit it or alert somebody or something like that, right?
Yeah. And part of our capabilities on is what we call auto rules. And so what that system does is it looks at the historical data over time for some groupings. For example, we frequently have it by default on a mode that's looking at sensitive data accessed by service over time. So we're able to say like, hey, the service is accessing this endpoint on this other service. And for every single request, it has this particular amount of sensitive information, like 1 or 2. It's getting back like 1 or 2 other types of specific kinds of sensitive information. And so we can look at that, we can create a statistical model around that and say like, hey, if we all of a sudden see like 20 pieces of sensitive information, that might be worth telling somebody about, or depending on the configuration, even proactively blocking.
Yeah, that's actually quite interesting. I think that we introduced such a capability to our WAF, which is called Cloud Armor. So the Google Cloud WAF, which is attached to Cloud Load Balancer, which has those sort of auto rules. So it can work in recommendation mode. So it can just recommend, hey, please apply this rule, or it can just actually apply the rule for you. The last time there was like an article about, I think less than a year ago, where we blocked, like one of our customers was using that and they were able to block one of the biggest DDoS attacks. It was like an incredible number of requests, like millions of requests. And they were not using it in auto mode. They were using it in like recommendation mode, but they were able to get like a notification to say like, hey, please apply this. We recommend you to apply this, right?
Yeah, click this rule and solve this problem. Exactly.
Yeah, so that's kind of proactive recommendation is actually quite interesting, right?
Yeah, and it really is. And that's where the industry's headed. Like if you look at Wiz Security, for example, right? They come in, scan everything in your environment and say, hey, this is kind of your cue for what you need to do. We're kind of that same thing, but on the production logic kind of platform engineering side, because, everyone's shifted left for the past 5 years and scanning every possible thing you can say, which is great. It's needed, right? But platform engineering really has not seen that level of love in terms of what does security mean when code is pushed to production. Are we going to let our old Akamai WAF or whatever WAF that might be protect all these services? Or are we going to do something else? And so that's really our stance on trying to bring this more to the right side of the equation.
Yeah, I do have a really big problem with the word shift left, because whenever I go around and talk to people about it, the immediate answer I get is developers thinking, well, suddenly we have to do more than we can or than we should. It makes it sound like you're just making developers responsible for everything, including security.
I was a developer for a long time, right? And developers can be security minded, but bringing in vendor tools and forcing them down a certain workflow and doing certain extra tasks, that has to be hard. I have not been in one of those environments lately, so I would love to hear what that is actually like on the front lines enforcing those things.
I think that the term is misused in the sense that what people mean by shift left is making people aware of what they're doing. So bringing that visibility, whatever that visibility means. Maybe I am a developer, I am using IDE, and then in the IDE, I can see like real-time scanning of packages that I am using or stuff like that. But I think to a lot of people, it just means now you are a developer and you have to understand how, data exfiltration works. And you have to work toward preventing that instead of just focusing on creating value for the business and having something else do that for you, right?
Right. That's right. Yeah.
Cool. So let's move forward then. We talked extensively about what LeakSignal does. So you folks support Envoy and Nginx via like a native module, AWS Lambda. And I see that you added to the doc we have shared earlier, eBPF. Like, do you support eBPF?
So it's an interesting story about eBPF. We do technically support it, but we don't have first-class support for it. We did a prototype implementation, and what we found is that existing eBPF vendors, they're doing all of their scanning inline in the kernel, which is great for performance, but it limits you because you're stuck to doing Turing complete, like guaranteed termination scanning. You can't run a regex engine in eBPF.
Yeah.
And so, for something that's doing a lot more complex scanning like ours, even if it's high performance, has to be moved into the user space. And so in order to support that, you end up having to do a lot of work around like handling like layer 4 packets. And we kind of found that it's like we were trying to fit a square peg into a round hole. It's just this kind of complex layer 7 logic doesn't really belong in the kernel. It really belongs in the layer before you go to the kernel. Now, if we have a customer that really needs to have that at the eBPF layer for, say, like supporting some legacy technology, we do have it.
Yeah, eBPF is this thing that was quite big. So every single year we go to KubeCon, there is always one of two technologies that is the thing of that version of KubeCon, right? So KubeCon, Valencia 2022, Europe. So eBPF was huge. Everybody was talking about it because everybody was saying this is the solution to the sidecars, right? And I always had that skeptical view at eBPF because I sort of understand how it works kind of at low level. And I'm like, doing, as you said, kernel level stuff, low level, low performance stuff, that's fine. Doing complex HTTP traffic analysis in eBPF, I really have questions about how that would work.
Yeah, there was a big push for eBPF and the technologies around it. It says it was observability, networking, and security, but the security part of this, like I really questioned, and it really comes down to blocking like IP level port activity. I mean, it's really good at doing that, right? But from our standpoint, like Max said, square peg, round hole, and it's not built to kind of do this sensitive data classification. That's for sure.
Yeah. I think only time will say how this will progress. I find the approach that Istio took with the ambient mesh quite interesting, which is essentially we're not going to do eBPF, right?
Yeah. So the whole sidecar versus waypoint proxy and the new architecture with Istio, I'm all for it, right? I'm not saying anything negative about it, but when you look at the enterprise, when you look at Fortune 500 companies and you see what they have deployed, it is all sidecar technology.
Yes.
Like architectures, right? And it's new, right? And I understand that it's going to take some time to adopt. But with a waypoint proxy, you're still dealing with Envoy layer 7. I mean, you still can do the whole, what we're doing, right, is deploying a proxy-wasm module into that environment. It's just the proxies at a different location. It's not on every service. So
yeah, I mean, the whole point of the ambient mesh is reduce the footprint of the sidecars, right? So instead of having one sidecar per pod, you would have one sidecar which is shared across an entire namespace and it's horizontally scalable. So if you have more traffic, you can just like add more sidecars.
Right.
But I think that the interesting thing with the implementation that Istio took is the Z tunnel, essentially. It's like building a new Rust-based tunnel instead of just doing eBPF like everybody else is doing pretty much for, the MTLS, the low-level stuff, the layer 4 stuff, right?
Right. Yeah. So I'll be interested to see how that progresses as adoption.
Yeah, I'm also looking forward. I mean, it just became available in 1.18, but it's an experimental. So I've been playing with it. It's pretty cool. It works the same way it worked before. But I think I have a question that would probably lead us to the end of this is, have you folks been looking at the gateway API in Kubernetes, right? Have you looked at that?
Yeah, we've taken a good look at that.
So I don't know if you're aware of this, but Istio is eventually going to move away from their own custom-built CRDs toward using the Gateway API for traffic management.
Yep.
I don't know if you have any thoughts about that.
I've got it deployed in my home cluster, the new Kubernetes Gateway APIs. I don't think it has too much direct impact on us, though.
Okay. Because so the future will look like traffic management in Istio, instead of using the destination rules and virtual services and all these CRDs, they will just use the Gateway API objects like the HTTP route, TCP route, SSL route, because they can do the same traffic management. So I think we'll see how the future goes, right?
Yeah. Part of our approach on like mapping out services, figuring out routing all is we're not looking at the control plane, which is I think why that doesn't impact us.
Oh yeah.
And so what we're doing is we're just looking at the actual communication, seeing where the traffic is actually going, not where it's configured to go.
Yeah, that's what I found interesting about LeakSignal, is that you don't actually rely on the Istio control plane, which makes it work across anything that has pretty much a proxy, right?
Exactly.
So it would also work with legacy systems, which is quite interesting. All right. Well, that concludes the questions I had for you folks. I learned quite a lot, got updated about how the project is going.
Yeah, that was great. And thanks for having us again. Appreciate it.
Thank you very much, folks. We'll have all the links to the conversation in the show notes. And thank you very much.
Thank you so much, Abdel, for that conversation with LeakSignal. I didn't know anything about this company coming into this, so I definitely learned some things here. Main thing I think I got out of that is proxy-wasm, proxy-wasm, proxy-wasm.
Yeah, we spoke quite a lot about proxy-wasm. So what happened is Wesley have reached out to me, I think, the beginning of COVID, because I did a talk with the Istio community, and he reached out and said, hey, let's have a chat. So we jumped on a call, we had a chat, and he explained to me what they were trying to build, right? Which is essentially the first idea of LeakSignal, which is, as we discussed in the interview, it's a plugin plus a cloud dashboard for detecting like data that is being siphoned out of your platform. And it supports anywhere where Envoy runs or whatever proxy supports proxy-wasm, which is why we spent quite a lot of time talking about it.
Which I think their name is pretty descriptive.
Yeah.
They're trying to provide you signals about leaks that are happening.
Yeah, I find the name kind of interesting and I find it genius.
It's pretty good.
Yeah. And it's actually interesting in the sense that their platform doesn't require you changing anything to your code, right? You just drop this thing, you drop Envoy, and then you add their plugin, which is WASM plugin. And that's it. That's all you have to do.
Which is a common thing that we say about service meshes too, right? It's something where you get additional functionality where you don't have to change the code.
Yeah.
And LeakSignal works with service meshes as well. So
yeah, I think, in my opinion, that's the beauty of this whole service mesh Envoy thingy, which is this inline processing you're able to do on requests as they're coming in and out of your service. And Envoy supported filters for a very long time, and people have been using WASM and using Lua to write this Envoy. But I think what these guys are doing, they're like actually giving you those plugins, so you don't really have to worry too much about it. And so this proxy-wasm is just offering a whole new set of capabilities.
And I also found the conversation about eBPF there at the end very interesting.
Oh, yeah.
It's nice to see a use case where eBPF is not a good fit. It's always important for any new technology, right?
Yeah.
Places where it's not great.
Yeah. I think for the kind of processing they do, doing it in eBPF would be almost impossible, right?
Yeah.
Which is why I find it very interesting when some companies claim that they're going to solve all the sidecar problems with eBPF. And I'm like, I'm wondering, how are you going to do this?
Some things that don't quite fit here.
Yeah. How are you going to do layer 7 authorization with Spiffy in the kernel? Please show me.
Yeah. And this conversation also hit on a lot of new and trending technologies, I feel like. A lot of talk about WASM. We mentioned eBPF. We're talking about all of these service mesh components like Envoy, proxies, all sorts of things here.
Yeah. And I mean, to be clear, like LeakSignal does not require service mesh. It just works with Envoy. So if you have Envoy, even if you don't have the mesh,
right,
as long as you have Envoy, we talked in the interview with a company that I couldn't mention their name, but there are a lot of companies using Envoy as a layer 7 proxy for their ingress traffic, right? And Envoy, you can run it on virtual machines, you can run it on physical servers, you can even run it on, I don't know if you know this, but they have Envoy mobile. You can actually run the proxy on the, yeah, there are some companies using that.
I made a face.
yeah, she made a very
was not expecting that.
Yeah, there is Envoy mobile. I think it's called Envoy Edge. I don't remember the name.
Okay, well, all right, that makes sense.
So you can do a lot of interesting things with it. I was looking into what's possible. Imagine you can do experiments on the phone of the user. So you can actually send the configuration to the Envoy proxy on the user phone to enable certain features in the app. So you can remotely change the behavior of the app.
I guess a network's a network, huh?
Yeah, exactly. Exactly. So I think that a lot of people made the same face you made when Envoy announced Envoy Mobile for the first time. They were like, what? And over time, I talked to people using it in super interesting ways. So
yeah, I would love to hear some use cases on that.
Yeah.
You got to look up some user studies there.
Yeah, we'll add some links to the show notes. But imagine things like, imagine being able to actually monitor traffic on a corp device, and you can prevent basically attacks and security problems on a corporate device, corporate phone, right? So
I remember the days when we weren't that worried about viruses and malware on phones because they were too new.
Yeah, those days are over, I guess.
We're past that point.
Yeah, exactly. So yeah, no, it was an interesting conversation.
Yeah, I definitely learned a lot. And I feel like I learned a lot about a lot of different technologies that I'm trying to learn all at the same time because they're all new and trending.
Yeah.
A lot of interesting use cases here.
And this space is moving so fast, it's actually kind of difficult to keep up with.
Really, I feel like WASM is still so new. A lot of people are very excited about it, but I haven't been hearing a whole lot of real use cases, but this one was one. So
yeah,
the more use cases I hear, the more I can learn about it.
Yeah, I mean, there is a dedicated conference for it now. So
yeah, that's true.
I guess that's the signal. Whenever the CNCF said we're going to do something con about this, it's big.
Yeah.
So.
All right. Well, thank you very much, Abdel. And we'll catch you all next time.
Thank you.
That brings us to the end of another episode. If you enjoyed the show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you'll find transcripts and show notes and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.